हेलो स्टूडेंट्स। आज मैं आपके लिए और एक प्रॉब्लम लाया हूँ। ये भी IIT 2025 में पूछा गया है। एक स्टैंडर्ड प्रॉब्लम है, ज़्यादा डिफिकल्ट भी नहीं है, मतलब एवरेज प्रॉब्लम है। तो मैं ये आपको सॉल्व करके देता हूँ। मैं ये नहीं कह रहा हूँ कि आई एम द फर्स्ट पर्सन टू सॉल्व दिस प्रॉब्लम. I won't be the last person to solve this problem. There will be many others who are going to solve this problem, और इसका solution बहुत टीचर्स ने दिया होगा। लेकिन it is the right of the student to compare the solutions and pick up the solution which is lucid, which is straightforward, and which involves less mathematics and which involves lot of clarity of concepts. पूरा प्रॉब्लम मैं आपको समझाऊंगा क्योंकि मैंने पूरा लिखा नहीं है। ये है, these are the two chambers containing gases. This contains 3/2 moles of an ideal gas. It contains 1 mole of an ideal gas. And between these two chambers, there is a piston, which is thermal conductor. I mean, heat can move across the conductor, across this what you call as partition or piston. अगर ये स्प्रिंग नहीं होता तो this piston would have been onto the right side, because on this side there would be more volume, क्योंकि इसमें ज्यादा number of moles है, इसमें only 1 mole है, it is 1.5 mole here, तो piston should have gone onto the right side. लेकिन when the piston tries to go onto the right side, the spring gets stretched and it creates a force in this direction. So with this spring and with the pressure here and with the pressure here, the spring is, the piston is in the middle, in equilibrium. The pressure here may be P1, here it will be P2, and P2 is given to be KL by A alpha, where A is the area of this piston. ये piston का surface area है, surface area. हमें क्या निकालना है? हमें ये अल्फा का वैल्यू निकालना है। बेसिकली हमें ये P2 निकालना है यहाँ से in some way, और फिर इस P2 को इस given P के साथ कंपेयर करके ये अल्फा निकाला जा सकता है। The problem boils down to what concept? That we have to find this P2. Okay, now see here. This piston is in equilibrium. This piston is basically in mechanical equilibrium, and it is also in thermal equilibrium. Mechanical equilibrium means the force on this side and this side is the same. अगर force same नहीं होगा on both sides, then the piston will begin to accelerate. But the piston is in equilibrium. I mean, it is at rest, or it may even move with a constant, slowly constant velocity. That means the same thing, but it is at rest. It is rest means the force on the left side and the force on the right side is the same. That is what you call as mechanical equilibrium. But the two gaseous systems from left and right, they are in thermal equilibrium also, because this piston is heat conducting. If there's a temperature difference, heat will conduct to keep the temperature constant. When we say the middle, this piston is a thermal conductor, means that both sides of the piston are at the same temperature. So the given condition is mechanical equilibrium and thermal equilibrium. That's all. So let me start doing the problem here. Have a look. पहली बात यह है कि this pressure will create force in this direction, this pressure will create force in this direction, and this spring, the natural length of the spring is 2/5L, and when the spring has this position or this state, it is extended length is L/2, but L/2 is greater than 2L/5. That means this spring stretches and it will create force in this direction. It has to, otherwise the piston will go on to the right side, because the number of moles here on this side is more. तो जब ये stretch होगा ये spring, तो force will be created in this direction. तो पहली बात ये है कि let me write the equation of what you call as mechanical equilibrium. That equation is, okay, P2A, this pressure into this area force to the left side, plus Kx, because this force due to pressure P2 and this force are in the same direction. It is on the left side, it is towards the left of the piston, is equal to P1A. This is the equation, what you call as equation of mechanical equilibrium of this piston. Now, what is this x? X is the extension. That is L by 2, the extended length of this spring, minus 2L by 5. That is 5 minus 4, that is 1 by 10. That is 0.110. Okay? So it is, so far it is simple. But now, this part of the chamber contains 3 by 2 moles of a gas at temperature T. So what should I write? But the volume here and here is the same. Let it be V, let it be V. So I will write equation here, that is P1V is equal to number of moles, that is 3 by 2 R and T. Write the equation on the right, for the right chamber of the, for the right chamber this, that is P2V is equal to number of moles is 1 RT. तो यहां मैं ये P1 निकालना चाहता हूं. जब ये P1 इन दो इक्वेशन में निकालूंगा वो मैं यहां रखूंगा और मुझे मिलेगा P2 और मैं P2 को कंपेयर करूंगा, ये अल्फा निकालूंगा. ठीक, तो डिवाइड कीजिए इन दो को, तो ये खत्म 3 by 2, V खत्म, तो P1 इज इक्वल टू 3 by 2 P2. अब इस P1 को यहां पर रख दो तो मुझे P2 वहां से मिलेगा. सो P2V, P2A plus KX, what is X? 0.1L is equal to P1, that is 3 by 2 P2. तो इस P2 को उधर ले जाइए, K 0.1L is equal to, इसको वहां ले जाने से, लेकिन ये तो P1 हो गया, A यहां आएगा, तो इसको वहां लेने से मुझे मिलेगा 1 by 2 P2A, राइट. तो मुझे मिलेगा P2 इज इक्वल टू 2K 0.1L डिवाइड बाई दिस A. इसको किसके साथ कंपेयर करना है? देखो यहां से मैंने P2 निकाला इन ए वेरी नाइस गुड मैनर विद इन a few equations, and these are the equations which you can just write from the given situation. तो वो जो P2 दिया हुआ है वो क्या है? That is KL by A alpha. इसको मैंने जानबूझकर P2 लिखा so that then you can compare with the given P that is given. इसके इस चैम्बर के लिए जो प्रेशर है वो दिया है क्वेश्चन में, तो वहां अल्फा निकालना है. ये K खत्म, A खत्म, L खत्म, तो अल्फा इज इक्वल टू 2 into 0.1, that will make it 0.2, but answer is possibly 1.5, 1 by 5, that's 2 by 10, that's 1 by 5. Alpha is 1 by 5. तो question is easily done. तो मैं ये कह रहा हूं कि मैं ये नहीं कह रहा हूं कि this is the question that I solved for the first time on the net. This question may have been solved by many teachers, and I am not the last person who has solved this question. There will be more people who are interested to do good physics. They will also solve the question on the online, but students have every right to compare the solutions, and to pick up a solution is most lucid and based on concepts. And don't forget to subscribe to my channel at the rate of Tantray Physics class. Thank you.